Today we're going to do a little bit of a review of writing equations. So this is Unit Notes 5A, which is writing equations. So this is going to be talking about setting up word problems. We're not going to be doing a ton of solving today. More or less, we're just going to be doing some setting up. So let's go ahead and take a look at this. So starting with number 1, after 22 games in 2005, J.D. Drew of the Los Angeles had 10 runs batted in. After 36 games, he had 15 runs batted in. Write a linear equation to represent this situation. So what we want to do for equations like this is we want to look at those as being almost like points. Okay, so let's write out points. Let's first write out a point for J.D. Drew of the LA Dodgers. Whoops. So after 22 games, so I'm going to let games be X, and I'm going to let runs be Y. So after 22 games, he had 10 runs. Then, after 36 games, he had 15 runs. Okay, so we want to start by finding the rate of change, so what his increase is. And we do that by calculating the slope. So if you remember that slope formula, that y2 minus y1 over x2 minus x1. So we have x1, y1, x2, y2. So let's go ahead and calculate out the slope. So we have y2 minus y1 over x2 minus x1. Okay, so 15 minus 10 is going to give us 5. 36 minus 22 gives us 14. So our slope is 5 over 14. Now, to write a linear equation, we learned 3 different forms of a linear equation. We learned slope-intercept, point-slope, and standard form. Okay, so let's go ahead and let's put this into point-slope form. So remember, for point-slope form, we set that one kind of up like a puzzle. Okay, so it's going to look like this. All right, then what we're going to do next is we are going to go ahead and we need to pick a point. So I'm going to pick this point right here, 22 and 10. So we're going to do, and I'm going to do the opposite. So the opposite of the y coordinate, minus 10. And here goes my slope. And then opposite of the x coordinate. And this right here is a linear equation. So this is all I want from you right now. That is a linear equation representing what happened for J.D. Drew of the Los Angeles Dodgers. If you wanted to graph it, you would have to solve this equation for y. But for what we're doing today, this answer is perfectly fine. So let's take a look at number 2. As a part-time job, Ethan makes deliveries for a caterer. In addition to his weekly salary, he is also paid $16, that says 16, I know it's kind of cut off, per delivery. Last week he made 5 deliveries and his total salary was $215. Write a linear equation for Ethan's total salary. So what we don't know is Ethan's weekly salary. So I'm going to call that B. Okay, we don't know his weekly salary. I do know for every X errand that he runs, he makes $16. Okay, so that's in addition to his weekly salary. And between all of that, that's going to be his total salary, Y. Okay, so what we're going to do is we're going to use the fact that with 5 deliveries, he got $215. So this I'm going to plug in for Y, and this I'm going to plug in for X. Okay, so let's go ahead and do that. So we have 215 is equal to 16 times 5 plus B. So now we need to go ahead and solve that. Well, 16 times 5 is going to be equal to 80 plus B. So now to solve for B, I need to subtract 80 from both sides. So then I get that B is equal to 135. So now we're going to take and look at this equation up here, and we're going to plug our B back in, and that's going to give us our linear equation. So I'm going to get Y is equal to 16x plus our B, which is 135. So this linear equation represents his weekly salary based on how many deliveries he makes. Let's take a look at number 3. Lilia and her friend rented a canoe for 3 hours and paid a total of $45. The rate was $10 per hour plus the cost of the daily rate. So we're going to write another linear equation for this. Okay, so rented a canoe for 3 hours and paid a total of $45 The rate was $10 per hour. So what we have here is an equation. We have our total cost is equal to $8 for every X hour that we're there, plus the cost of the daily rate. But we don't know the daily rate right now. Okay, so that's where we're going to use a point. So this 3 hours is going to represent our X. This $45 is going to represent our Y. Okay, so we're going to go ahead and plug that in so we can get our daily rate. So we paid $45 when we were there for 3 hours. So we're going to do 8 times 3 plus B. So now we need to solve this for B. So we have 45 is equal to 24. Oh, it's $10, not $8. Oh, geez, Miss Humbert, you are a mess. Okay, so let's go ahead and fix that. So this should be $10. I'm sorry. You're probably wondering what I was doing. So that's $10. So then 30 plus B. So now to solve for B, we're going to subtract 30 from both sides. Subtract 30 from both sides, if it'll let me. There we go. So then we get that B is equal to $15. So that's our daily rate, is the $15. So now we want to go ahead and we want to plug that in to our original equation here. So instead of writing B, I'm going to write $15, and that's my linear equation. So this right here is your final answer. Let's take a look at number 4. Yvonne and her friends held a bake sale to benefit the shelter for homeless people. The friends sold 22 cakes on the first day and 15 cakes on the second day. They collected $88 on the first day and $60 on the second day. Let X represent the number of cakes sold, so that's really important. X represents the number of cakes sold and Y represents the money made. So now we need to find the slope. So that's going to be kind of like number 1 when we made 2 points. So let's go ahead and do that. So friends sold 22 cakes, that's X, on the first day, and 15 cakes on the second day. So those are our X points for our 2 coordinates. So we have X, and we have X. They collected $88 on the first day. That's our first Y. Oops. Should probably put in the number, huh? $88. And then $60 on the second day, which is here. So now we're going to go ahead and we're going to calculate the slope between those 2 points. So I'm going to do Y2 minus Y1, 60 minus 88, and then Y2, or X2 minus X1, so 15 minus 22. So then I get negative 28 divided by negative 7. Remember that 2 negatives are going to equal a positive, so that's going to become plus plus. 28 divided by 7 is going to give us 4. So that was our rate of change, was 4. Okay, let's take a look at number 5. Your grandmother made 240 ounces of jelly. There are 2 types of jars. The first holds 10 ounce, so I'm going to let X represent the 10 ounce jar. The second holds 12 ounce, so I'm going to let Y represent the 12 ounce. Write an equation to represent the different number of 10 ounce jars X and 12 ounce jars Y that will hold all of the jelly. So we have 240 ounces that we need to hold. So first we have X number of 10 ounce jars. So, excuse me, so that's kind of confusing. Okay, so we have 10 ounce jars, so you have to think, okay, how much does a 10 ounce jar hold? Well, it holds 10 ounces. So for every X 10 ounce jar we have, it's going to hold 10 ounces. Then guess what? For every Y 12 ounce jar we have, it's going to hold 12 ounces. And that's all you have to do. It didn't ask us to graph it. It didn't ask us to do anything. It just asked us to set up the equation. Okay, so this is the equation right here. It's in standard form. Now, if you needed to graph it, you would have to go ahead and solve for Y. Let's take a look at number 6. You're buying $30 worth of bird seed that contains 2 types of seed. Thistle seed attracts finches and costs $2 per pound. Dark oil sunflower seed attracts many kinds of sunbirds and costs $1.50 per pound. Write an equation that represents a different amount of $2 thistle seed X and $100 or $1.50 dark oil sunflower seed Y that you could buy. So we have $30. Now we're going to write this one as an inequality, and here's why. We have $30 to spend. We could spend exactly $30, but we also have the choice of spending less than $30 if we want. Okay, so for every X pound of thistle seed that I buy, it's going to cost me $2. For every Y pound of thistle seed, for dark oil sunflower seed I buy, it's going to cost me $1.50. And that's your equation. It's all set up here. Okay, that's all you had to do. If you needed to graph it, you'd have to solve for Y, but the question, it doesn't ask us to do that. Okay, next, let's take a look at 7 and 8. So candy corn costs $2 per pound. I'm going to let X represent my candy corn. And M&Ms cost $3 per pound. I'm going to let Y represent that. With $30 to spend, how many different amount of the two candies can you buy? Once again, we can spend up to $30. We can't spend over $30. Okay, whatever we spend has to be less than $30, but we do have the choice of spending exactly $30. That's what that line underneath the inequality means, is that you could spend less than or equal to $30. So for every X pound of candy corn that I buy, it's going to cost me $2. For every Y pound of M&Ms, it's going to cost me $3. And that's your equation in standard form right there. Again, if you needed to graph it, you'd have to solve for Y. But we're not worrying about that for this one. Let's take a look at number 8. Suppose you had $6 to buy bananas and apples. So whatever we spend, it has to be less than or equal to $6. We don't have more than $6, but we do have the choice of spending less than $6. So bananas, I'm going to let be represented by X. And apples, I'm going to let be represented by Y. So bananas cost 49 cents per pound. So for every X pound of banana I buy, it's going to cost me 49 cents. Apples cost 34 cents per pound. So every Y pound of apples that I buy, it's going to cost me 34 cents. And that's your final equation. So I wanted to go through and set up all of these for you because I know that sometimes word problems can be really tricky. So do ask me for help if you have problems getting it set up. And hopefully this went well. Show me your note sheet when you're done. Thanks for listening.